Hi there, Glenn here, and welcome to part 2 of the Asteroid tutorial. And as I said in the previous one, we're going to make this asteroid look a little bit more interesting, shall we say. So, picking up from where we left off last, let's let the asteroid, space G, warm it up. I'm going to put another camera in, just for a couple of test renders. So for this, I'm going to hide the planet, I'm going to hide the environment, not interested in that in the slightest. I'm going to come to this, I'm going to turn off preview, do a render, see how we're looking. Interesting. So let's try and go from the camera that I've just placed in. Okay, now I'm looking at this and I'm not seeing a great deal of the green that we actually put in. So let's go over to shop. Let's go Asteroid. And if we think back, this was the diffuse leg of the network. This is the green colour and this primary colour being mixed together. So this will be the control of how the green sits on the surface of this. So let's make it a little bit gaudy, take the attenuation right down, and you should significantly see the green involved in there now, which it is. Lovely. So as I said before, subtlety is the key here. I want it to be ever so slight, don't want it to be overpowering. It's entirely up to you how much you want in there. But, you know, the stronger the colours clash, you know, the more clown looking it's going to be. So, choice is yours. But I'm going to leave that. I can definitely see some hints of green in there, you know, as you can see around there, some nice hints of green. So, that's okay. So, that just makes it a little bit more interesting on the asteroid itself. So, where do we go from here? Well, I did put a little bit of thought into this. This next bit, we'll come back to OBJ and get out of, well, in fact, the second camera, the one we just put in, we can nuke that out because we don't need it. Don't need it in the slightest. So let's jump into this camera and bring this up. Okay, asteroid's here, not particularly interesting on its own. It's gonna need some debris following along with it. So, what we're going to do is jump in the asteroid, okay, and I'm going to get a sphere, okay, and I'm going to, well actually I'm going to leave display on there and I'm just going to template this, and then I'm going to increase the radius until we have the sphere popping out of the asteroid, like so. And I'm going to change it to polygon, because we seem to be doing alright with these polygons. So now, as we can see, it's moving that way across our screen. So I'm going to want it a little bit in front, but I'm definitely going to want it a little, quite significantly behind. So let's scale it this way, and then I'm going to move the center back, like so. And I'm going to extend the scale like that because it wants to encompass all of the asteroid. And I'm just going to displace these points with the mountain top as we've done previously. I'm just going to really crank the height and the frequency because we don't want it too high. We definitely want it a bit jittery, to say the least, and that's going to do for now. We've only got 42 points in there, so that's fine. Now I'm going to add an add. Okay, I'm just going to delete the geometry, keep the points. So now we have a bunch of points flying along with it. I don't know how easy it is for you guys to see on the recording, so just for visualization, so you can see what's going on. But could quite possibly be a hint on what will be happening next. Let's There we go. So as you can see, we have this bunch of points just flying around. Okay, so this is going to be the base for our debris. I'll set that radius back to the way it was. Okay, if you want to be a little bit clever about this, like you don't want any of the debris intersecting into the sphere, that's perfectly fine. We can do that. Houdini's smart enough to do that. So we get a group, we've got two inputs, we've got source data, and we've got bounding object. So we can put these points in here, and we can put them in there, okay? And we shall call it inside group, and $OS there, which will just basically take whatever the node name is and use that. So if we middle click on here, you can see 0 primitives in inside group. So it's just taking the name from the node and putting it into the group name. We do want to be on points. We don't want number enabled, because that's enabled by default. Bounding enable, bounding box, bounding object, and it's reading it from here. So if we middle click on here, we have 1 point in inside group. So there's only 1 point in there at this moment in time. So what we can do then is we can drop a delete in, okay, and then we can delete the inside group like that. And if we delete non-selected, take that away, you can see we do only have that 1 point, which is located within the bounding area of our sphere. Okay, so it's working as intended. That's totally fine. We'll put that back to delete selected. So now we have a bunch of points that are following our asteroid beautifully. So let us come to about here. Okay, now what I said about this being a hint as to what's happening next is pretty much the truth. So the sphere that we've got here, okay, again we're going to go with a polygon. We're going to give it a frequency of 5 because we don't want it too dense, and we are going to mountain stop again just for ease basically, and then I'm going to pop down a transform node, okay, and all will be revealed very shortly. So we'll put that into there, come back to our camera view, and as we can see we do have displaced geometry on our points, except the problem is that it's all displaced the same way. Okay, everything is identical. So what we need to do is we need to think of a procedural way to deal with that, and copy stamping is going to be the way forward because there's not a great deal of geometry in here, so it's going to be fairly zippy. So what I'm going to do is I'm going to come to stamp, and I'm immediately going to pack geometry before copying. Okay, so that's going to give us a packed geometry. So this is going to save us on system resources. Yeah, that's going to save us on system resources. So if we look here, we've got 41 packed geometry. If we undo that, we now have 20,500 polygons. Okay, so you see what it's doing there? It's wrapping it up. And let's have a look here. Memory. So 24 down to 23. Okay, we'll pack it. That's fine. What else we're going to do is we are going to change the look of these procedurally. So let's get on with that. I'm going to create a couple of variables here, and we shall start with first page will do. So height. So this is going to be the height of the mountain top. So I'm going to give it a random value. Everything on here is going to be a random value based on $PT at the moment, which is the incoming point number. And I'm just going to give it a multiplication, just for just to shake it up, give it a different seed value before it does its calculation, sort of thing. So height. What else do we need? Well, I'm going to go scale X and give it a random value in there as well. So $PT, and give it a different seed value. And I'm going to go scale Y again, random $PT times something else. I'm going to go scale Z, give that a renad. I don't know what renad is. And $PT times, yeah, I want it over 1. So we've got height, scale X, scale Y, scale Z. I'm going to also have U scale, okay, and that's going to be rand again, $PT, blah 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 blah, and also rot Y for rotation Y. This is going to be a random value, but what we're going to do is going to go $PT, blah blah blah. I'm going to put a multiplier outside of this, and the multiplier, think of this number as degrees of rotation, because rot Y is going to be rotation Y. So I'm going to do it over 1070, because that's a decent rotation amount. Obviously nothing's happened here, because even though we've input these values, we haven't told it where it's going to be input. So what we're going to do is start with the, hang on a minute, there's something I've left off there. I also want offset. And again, rand $PT. There we go. Right, okay. So with this, let's get these values input. So we've got height, scales in 3 axes. We've got a uniform scale, a rotation Y, and an offset. So we'll come to the mountain. And height, let's click in there and we'll write stamp on plus parentheses, and we want to point this at the copy 1 node, and this wants to be height and with 0 on there, and I'm going to control A to select it, control C to copy it, and just hit enter. Okay, and as you can see, everything has gone kind of flat. All of them have gone pretty much back to being sphere-like, which is not a problem. Stamp down copy 1 height. Did I spell height the same? So it's one of those funny ones with the E and the I. Offset, so I'm going to pop that in there, and I'm going to call this offset. Okay, let's come to scale here. I'm going to change this to, as you've guessed, scale X, tab, and I'm going to go with scale Y, and then scale Z. Okay, rotation Y, we paste that in there, and it's going to be rot Y, and then uniform scale is going to be U scale. So everything has gone ridiculously tiny. Okay, and if we just click the value on there, and this is why everything's gone tiny, apart from the rotation, which is large, everything is less than 1. Why is that happening? Because when you pull a random function, it gives you a pseudo-random number between 0 and 1. But obviously we're getting different values in there because we've added a seed, and the seed is calculating a different value. So it's yeah, we can change stuff around, and first thing we're going to need to do is definitely going to need to change the scale on these. So go U scale, okay, and we could wrap this in a fit 0 to 1 function, okay, and go, I don't know, 2 to 3. See what that gives us. Nothing at the minute. And it should be doing. Yeah, something somewhere is not right. Where are you? When something's not right, it's usually a typo. Let's multiply that by something stupid like 10 or 100. So the value is working. U scale, scale X, scale Y, scale Z. Scale X, scale Y, scale Z. That should, in fact, be working. Why is it not working? Let's try this again. Stamp. Copy one. And this is going to be scale X. You see now that's working. Put that back in there. We smash out the uniform scale. Delete that. Delete that. Nah, there we go. Didn't stamp the inputs, did I? There we go. Absolute total annotate user default. Thinking about too many things at once and completely ignoring that damn thing. Oh well, there we go. Yep, everybody gets caught out. Everybody gets caught out. So take that down. These are now ultimately tiny. So now we've got a multiplication of a number, we can actually use a scale ladder to scale things up a bit. Don't know how I didn't see that fool. Anyway, I digress. Let's go to the back to the camera. Back to the camera. And we've got some reasonable sizes going on there. Let's look at this. Height. Multiply that by 2. So we've got some different shapes going on, perhaps. That's too much. So 1.2. Okay, that's looking okay. So how many have we got there? We've got 252 points. Well, that primitive, so 252 points, 500 polygons. I mean, we could put up to 10 if we wanted to. But yeah. So let's drop in the camera view, and let's do this. Okay, we'll put a null down here, and I'm just going to call this rock out. Okay, I'm going to get another null down here. Let's just keep things tidy, and as we need to see it, we shall call this chunks out. Okay, so we've got rocks out and chunks out. Cool. I'm going to put our visibility back on rock, and let's come back up. Now, let's get a geometry container here, and we'll call this chunk. Dive inside, delete that, and drop an object merge. What we're going to do is we're going to merge in our chunks that we just did there. So there we have it. We have our chunks in the scene. So that's okay, that's fine. Problem is, it's not moving. Well, why is it not moving? And this is something that catches people out quite a bit. What's going on is sometimes it's quite hard to explain. The animation here is going on at object level. Okay, remember the asteroid is attached to the path, but the point is the asteroid's moving along the path. So as far as the asteroid's concerned, there's no values in the translate, in the rotate, the scale, or anything. So there's no translation going on this geometry node whatsoever. It's all happening on the asteroid path, because we are on this path, and we are moving along a position based from 0 to 1 along this path. So that's why we're not getting the animation that we're looking for. So how we remedy this, if we put that as far away as possible, how we remedy this is we come back to this object merge, where it says transform into specified object into this object. And there we go. What we've done now is we've pulled the values from the curve, from the position on the curve that the asteroid's following. So we now do have the animation coming along. So we've got these chunky bits going on here now. So that's okay. That's fine. So that's the chunk. Let's do a quick render. Okay, obviously we've no shader assigned to this, so you know the bright light's blowing it all out, sort of thing. So what we can do is we're just going to cheat basically. We're going to get the asteroid and copy paste this because it's going to be a part of the asteroid geometry. So we'll just call this chunks. Let's drag that on. Now we've got some horrible bulbous spiky things, and this is because, don't forget, we've really cranked up displacement on the asteroid shader because we scaled it up, but these are small pieces now that this shader's attached to because we just copy and pasted it. So we need to jump back inside, and I'm going to come with the main displace noise and I'm going to take that back down to possibly 1 because we're not going to need masses of displacement on these because they're only small objects when all's said and done. So we should take the scale 3 down to probably scale 1.2. See what we get with that, and let's just draw a box around there. So that's looking alright. How are you looking? That's looking alright. It's not looking too bad. Let's do a quicken. So there we go. That's looking acceptably better as far as I'm concerned. And before we start moving on to something else, let's come to here, come to rendering, allow motion blur. Okay. Now this rock is starting to get motion blur on it, as you can see, but the chunks won't. And if you're doing it and you don't get motion blur on there, just come to your asteroid node, come to the render, sampling, check on geometry, velocity blur. Okay, so we're now getting the blurring effect going on there, so that's fine. Let's do the same for the chunks. Hit geometry, velocity blur, and as it's rendering around, you'll notice what's going on. They're not blurring. That's because when you jump inside, this is all we've got in here, nothing else. We need to calculate the velocity, so we can do that with a trail sop. And it's as simple as just compute velocity. Now we should see some. There we go. Now we've definitely got motion blur on there. There we are. Okay, so that's the motion blur part dealt with. So let's take a look at what else we can do. So, whoops, let's get the asteroid. We want to look at the asteroid. So we know the asteroid is moving this way across the screen. Now, wouldn't it be nice to have a bit of dust coming off this? Well, that's pretty easy to do, to be fair. And I'm going to build this inside the asteroid here. So where we've got this rock out, we are going to get a grid. Okay, put it down here. So let's scale this grid up so we can see it. Might help put that on. Right, so the grid is now quite obviously bigger than the rock, so we need to change its orientation to XY. Let's look at this. Now I want it in front of the asteroid, so I'm just going to play with the Z center and put it in front. Now I'm going to look at this and I'm going to start messing about with size because I don't want it to be bigger than the asteroid. And you'll see why in a minute. So there we go. Now I've got this grid. This is going to be a particle emitter basically. So we're going to be kind of smart about this. So I'm going to move this here and I'm going to drop down a ray sop. Okay, and what I'm going to do is I'm going to project these points onto this surface. Okay, as you can see, it's a bit funky at the moment, so that's just projecting rays. I'm going to go minimum distance. So yeah, okay, it's squashed it up a little bit, but that's perfectly fine for what we're after. What I'm going to do is I need to lift it off the surface a little bit, so I'm just going to use the lift just to bring it forward. What we're going to do is we're going to birth particles from here, have it collide with the rock geometry, excuse me, and basically slide off. Okay, and that's where it's going to be coming from. So with that, I'm going to put scatter on there. I'm going to scatter just the default amount of points on there. Thousands are more than enough. We're not going to be birthing anywhere near that, but it'll definitely give it enough points in there to randomly generate particles from across the whole width of that, which is fine. So let's drop down another null, and I'm going to call it emitter out. Okay, now I'm going to put the visualization back on the rock. So we've done the chunks and we've set ourselves up a base of emissions. So let's get a geometry container and call this particles. Let's jump inside. Again, we're going to object merge, and we're going to go to the asteroid emitter out, relative path, and we're not seeing anything at the moment. And we do have 1,000 points in here because it says so there. Okay, and that's the amount of points that we scattered. If you wanted to do it a little bit differently, let's get rid of the scatter, should I say? Pop that back in there. Let's jump in here, and there we go. Let's put that scatter back, I think. These particles, you know, just want to deal with points, and of course I'm tripping up over my own stupidity yet again, because hey, it's not following the animation like before, so we need to into this object, and now is where the camera was located previously when I couldn't see it. So as you can see, we now have that following the animation again. So reset it to 0, obviously because it's a particle system, so it has to cook from the first frame. So we've got this, and let's go into a pop network old. Alright, so this object merge, I'm going to rename it to emitter in, and let's copy paste that, and I'm going to call this rock in. So where it says emitter there, I'm just going to change that to rock. If you remember, we did rock out as well. So now we have them both in here again, and I'm going to pipe this into the second input or second context, and then jump inside. Drop down source node because we need something to birth from. We're going to use the first context geometry, which is the points that we just input. We're on emission type points ordered. I want points random. So what I'm going to do now is life expectancy. I'm going to put that down to 1 and 0.85. Okay, so I want them to start dying off fairly rapidly, or at quite a random thing. I'm going to set the initial velocity. I'm going to set the velocity to 0, and let's have a look at what we get here. So let's look at our camera. Best put points on so we can see. Really uninteresting, but that's okay. So let's drop down a collision node. Okay, and now we want to use the second context geometry, and it's translating because it's moving through space, so we need to give it a hint that it's animated. And the behavior, I'm just going to slide on collision. So see what we get now. Much more interesting. Far more interesting than it was, and we don't want it to go too mad, so we'll stick a drag in there. You don't get much drag in space, but it is supposed to be in the very upper atmosphere of the planet, or close to it. As you can see, they're being birthed and they're sliding up and over the surface of the geometry. But that's not interesting enough, is it? So let's come in here and add a 0 on there, so we get 1,000 particles in there. So that's 1,000. Bearing in mind this is 1,000 particles a second, so every 24 frames it's generating 1,000 particles, and they're dying off fairly quickly as well. So let's see what we're looking like now. Definitely more interesting, that is for sure. Right. So we can definitely see these points because obviously, well, just points are automatically rendered as spheres in Houdini. That's how Mantra actually sees it unless you change it. So what we're getting is we're getting tiny little spheres being rendered. I do apologise about that. That was a cold call. So apologies for that extra break there. That was a postman. So yeah, I'm getting inundated with stuff this morning. So yeah, we were on about particles and the way Houdini renders them. So yeah, that has points, and we are on frame 67. So let's take a snap of that. Let's turn this back because the particle system will need to recook. Stop that now. And let's add some colour because at the moment they're pretty silver. We don't want that. So we shall add a colour. I'm going to come to parameter, right click, delete channel, and then we'll get ourselves a darkish brown to keep it into what we're actually dealing with. Now, as the particles die, they're just going to instantly disappear. I don't really want that. That's not my kind of bag, baby. So I'm going to add another colour down to here. Okay, and this time I'm going to go to the alpha tab. I'm going to come to ramp. Now, this is going to be based over the life of the particles because we set life expectancy on here. Okay, one of the attributes we've got is life, so we're going to utilise that for the alpha. I'm just going to left click on the lookup there, and I'm going to go $LIFE, $life. So this is going to be over the life of the particle. So if you imagine the particle's born here, and this is when the particle dies. This is on an individual particle basis. Okay, so you think this is the life of a particle. Okay, so I'm going to drag that up there, and I'm going to drag that down there, and I'm going to go with monotone cubic for the interpolation. Okay, and then I'm going to put another point in, and I'm going to put it up to there. So they're going to start fading away, and the alpha is going to let them disappear before they actually die, so that should reduce the pop-in of them just vanishing completely. So that's with that, and where was we? We was on frame 67. So I'll come back to scene view and hit 67. There we go. And now let's go back to here and do a render. See what the difference is. Okay, not a great deal you can tell just yet, but if you do slide between the two, there is definitely a colour change on there. So let's jump back up to here. We don't need to recook the particle system for what we're doing now, so we can just render it off. Now I've got horses walking past. So yeah, let's go with material palette. We're just going to go with the mantra surface node here. We'll just call this particles, and hopefully I can drag and drop it onto a particle. Nope, it's too small for me to click on, so we'll do it that way. Particle, and let's go with particles. Okay, so what's going to happen here is it's going to look like they've disappeared. Okay, hit the alpha channel, you can still see they are there. But the difference is, what Mantra's doing now is I've dropped that shader on there, and obviously you're getting the full effects of a shader rather than just the point colours being rendered from the geometry level. So you're getting your, reflections and specularity and stuff like that. But Houdini's shaders that are built in are smart enough to use the point colour, so it's still taking the colour from the particle system that we've done, because we're middle mouse on here. Point attributes CD. There we are. That's the colour diffuse 3 floors. Okay. So that's taking the colour from there. So these are all very, very tiny, all the same size. So we're going to create an attribute outside of the particle system, so we don't have to recook the particle system again. And we're going to call this P scale, because this is an attribute. Oh, don't be crashing. It crashed on me this morning. So P scale attribute. Okay, so I'm just going to go 0.1 for now. Let's see what's changed. Hit the alpha channel, it's still there. Let's go with a value of 1. And as you can see now, we are scaling the particles up. Okay, using the P-scale attribute, which is an attribute that is already in Houdini, so we're just accessing it, basically. So it's not really creating an attribute, it's an attribute that's already there. So what we can do now is add some random values into this as well. So obviously a value of 1 is far too big, so we'll go something like 0.5 multiplied by rand. We're not going to go PT this time, we're going to go ID. Okay, and ID as something that comes free with particles. The difference between $PT and $ID is when you have $PT, when a point number dies or gets removed from the scene, the next point, the very next point that's generated starts at 0 again and starts working up 0, 1, 2, 3, 4, 5, 6, 7. ID in the particle network doesn't do that. Once for argument's sake, particle 42 dies, that number will never be reused. So it'll be a consistently different value each and every time. So this is why, if there's a particle system involved, I will use ID, because it's never going to repeat in any way, shape or form. So that's why I'm using ID on here. So it's constantly generating a different ID. And what we need to do now is, again, go to here and get some blur on there. Okay, which we don't need to add a trail stop because it's particles. One of the point attributes here is in fact V for velocity, so we actually have a velocity attribute on here. So we don't need to calculate it with a trail stop. So that's fine. Excuse me, my throat's playing up a bit today. I mean, is that enough? Is that enough particles? I don't know, I mean, let's have a look. I mean, they're definitely there. They are very faint. Let's be bold. Let's be bold. So we can always turn it back now. So let's add another 0 on there. This is going to be crazy. Okay, lots of particles now. Lots and lots and lots. See what the render tells us. Okay, now we've got a lot of particles in the scene. The scale of these particles is too great now for my liking. Definitely too great. So we can just lower the value, not too far though. Oh, we are going to give up Facebook. You know, it's driving me insane now. Go away. So that's probably too low now. Let's just try and find a happy medium. That's better. I'm liking the look of that. And let's come back here, turn on the planet and turn on the environment, and we're getting an error. Okay, and nothing to worry about. Houdini sometimes does this if you don't have your path set correctly. So it's going to come out a salmon pink. It's using a texture map, and Houdini saying, I can't find this picture, I've forgotten where you put it. Not a problem. Not a problem in the slightest. Oops, OBJ. Go back to shop. go to planet, go back to surface. We don't need to deal with the displacement because we're channel referencing this parameter, so we only need to change this parameter, and if we open this it's saying the direction does not exist. No, it does, so it's not really a problem. So just go back to pictures and get our image Earth in there, fire off another render, and everything will be tickety-boo. There'll be no window popping up saying don't like this. So we're getting colour change in the particles again because as default the shader that we've used for the particles, with it just being a default material mantra surface shader that side effects built itself, it comes on with specularity already actually on, switched on basically. So this is why there is a definite colour difference, but yeah, I think things are looking okie dokie, to be honest. Let's have another look. See what it looks like from far away. So you may need to reduce the size of these. They are a bit large. Are they? I don't know. I don't want too many because I don't want to overkill it. It just wants to be fairly subtle. You know, a few chunks flying along at the same pace. So that, yeah, that's looking all right to me. Is that? It's definitely looking all right. I mean, these here are definitely it's definitely the ends of the corners of the grid, without a doubt. And we should, in theory, we're going to need to change it for the environment because we actually copy pasted that, didn't we? So because we were smart enough to channel reference the grid size with the box, we should, in theory, not that one, we should be able to stretch it out a tad, and the box will follow, so it shouldn't break anything. Let's do another render, and hopefully we should have got rid of those horrible corner jaggies. Okay, as you can see, we're losing the definition of the environment. Okay, because we've actually altered the bottom, the actual layer it was copied off, but we didn't reference those channels, which we're going to do right now. So grid size, I'm going to copy that parameter, going to jump into the environment, grid, and I'm going to paste that copied relative reference, and that should, in theory, have resolved that issue. There's only one more issue I want to get out of the way before we pull this to a close, and that is the path the asteroid is following. If you remember, it's got that horrible lump in it. So yeah, that's working as intended. Definitely. Let me just have a look at this and make sure that edge, yeah, it's totally off the side of that now. So let's take a look at our asteroid path basically. So where are we? Asteroid path, space G, let's turn it on, space G, let's go into front view. Let's jump inside. I want to ghost everything else so I can keep an eye on exactly what's going on. We've already got the edit SOP enabled, so select T, and I'm going to raise this a little bit, and then raise that. I'm going to select this one, I'm going to raise this one up a little bit, so we've just got a far gentler curve running across, so to speak. So let's jump back into our camera view, and I'm going to right click here, I'm going to do a quick flip book. It's already on referencing the start and end frame, so let's just have a look. Make sure it's not popping and bobbing as it was before. So it's just a smoother transition. Okay, it's still dipping down a bit for my liking, but we are up to 45 minutes. I did an hour on the first one, which was a lot longer than I'd actually expected. So I need to be thinking about pulling this to a close. And I'm going to change this to zigzag, and let's just have a look. And the particles are definitely intersecting with the surface, which I'm definitely not fond of. So back in here, let's do some alterations to this. Make it a far more gradual curve. Let's get into here. Turn off the asteroid path because I don't want to see it. Let's do another quick flip book. And again, I'm going to set that to zigzag so I can watch it backwards and forwards. Try and get a feel for it. So yeah, this tutorial has actually gone on for longer than I expected, but we've run into a few issues. I will manage to sort them. I don't think they're intersecting now. Which is good, but then you've also got to think, you're not seeing the alpha here, you're just seeing the particles die. So the particles are there's quite a big chance it could be invisible before they actually get that far. And away it goes. That's much better. Yep, I'm definitely liking that now. So with that, I'm going to go File, Save. Hopefully you've saved yours. So what have we got? Asteroids on, planets on, chunks, particles, they're all on. So start off a final render. I'm going to keep the pixel samples down to a low 3 to 3. You know, you probably don't want to go much further than 6 by 6. Because obviously, it's going to make the motion blur a lot better and stuff like that. So if you're a V-Ray fan, you don't like the interactive where it starts at the middle and goes out, you prefer a Hilbert curve, then you can go image, output, metadata, template tile order. You can go with the Hilbert curve. I'm going to go to rendering now, and I'm going to go to render. I'm going to up that to 32 just to have some bigger buckets. And then I'm going to render frame range, and I'm going to hit render to mplay. Okay, so we're not going to be using the interactive rendering engine now. We're actually firing up Mantra itself instead of using IPR. And we're going to set off render. Oh, before I do, possibly you might want some stars in the background. Maybe you do, maybe you don't, but let's go for it anyway. So we'll just call this stars. And let's jump inside. Now I may as well take the radius up in hundreds, because it needs to encompass the whole scene. If you remember, the grid was it 1,000 by 1,000, or was it 500 in the end? Can't remember. Whoa, what's going on there? Okay, so we now have an environment basically. So I'm going to drag that down because we don't need it as a perfect circle for what we're going to do here. So I'm just going to scatter. So again, there's 1,000 points on there. That's not really a problem. I'm going to go to colour. I mean, this is just a cheap and dirty way of getting a star, sort of like a star field sort of colour. Point, constant, let's go random. Okay, so we're getting random colours on all of them now. And we'll go to our material palette, and we shall go to utility, constant. I'm going to put constant actually onto them at the back there. Let's come back to our IPR render and just sort of render this section. and see what we get. Again, we're not seeing a great deal. If we look back there, there is, in that section there, there's definitely quite a few in there. So what we're going to need to do is do what I've done before. Because it's point rendering, we can use the same attribute create as we did before with p-scale, because it's a point. It's going to be point rendering, so this should work beautifully. So p-scale, value of 0, don't want that, does it? So let's just put a value of 1, and as we can see, we're definitely getting a value of 1 in there. So what will we like as a base value? So 0.2, possibly 0.3, and we'll do it again. We'll multiply that by random $pt times something or other. So now we've got some random sizes going in there, and if you look at p-scale attribute here, it is assigned a different value between 0 and 1. If you wanted to increase outside that, you could wrap the fit 0 and 1 function around like we showed earlier on, and that would work perfectly fine. So we're definitely getting cancel that off. Don't like the way it was thinking about that. Last thing I wanted to do was crash. So there we go. We've definitely got a few starter bits in there. Material palette constant, and the colour that's coming in there. I mean, you could. Actually, that's not going to do it, is it? So we could double click on that, jump inside, and you could multiply your output colour by another value if you wanted to, I believe. Yeah, can either multiply it or multiply constant. Anyway, whatever, you can multiply that by a value and get it being an emission sort of thing. Unless you want to use a glow again, use the emission value on there. I mean, that's doable. It's definitely doable. But I'm not going to do that. I'm going to call that a do, and let's save that up. Go to out, and I'm going to render to mplay. So let it come up and start doing a bit of a render. And there she goes rendering away, and I can definitely see stars. Oh well, points in the distance anyway. But obviously you're going to separate these out into render passes and composite them back in, and when you do, stars that are in the background, give them some glow. Definitely give them some glow. I went with random colours. You can go whatever you want, just white ones, blue ones, or whatever you see fit. So with that, it's, yeah, I understand there's still some bending and deformation around there, but as this is a tutorial and we're running out of time, I'm going to leave that up to you to fiddle about with the lattice deformer that we created, just to make sure it's all sat properly. So with that, I'm going to leave this rendering. I'm going to say goodbye to you all, and I hope you've enjoyed it. I really do. Again, give us a like if you've enjoyed it, and I should possibly do some more. And yeah, do some finished articles yourself, stick them in the comments, let me have a look at them, see how you guys have done. So yep, anything to say, drop it in the comments, give us a like, and thank you for your time. Thanks for watching.